We're going to look at an example on how to use technology to not only calculate or graph, use a scatter plot of a data set, but also how to use technology to find that correlation coefficient. We're going to do this for the example we were discussing at the beginning of the lecture with our club head speed and distance the ball would travel. So in order to find not only the scatter plot, but also the linear correlation coefficient, we're going to go to a place. I usually go to some place different than what the textbook describes. So I'll go to stat, regression, simple linear. And we discussed that the explanatory variable or the x variable is going to be the club head speed. The y variable or response variable will be the distance the ball travels. There's nothing else in here that I need to really worry with, so I'm going to hit compute. We can see here that we have one of two screens that are showing, and so I'm going to arrow over to the second screen so we can talk about the scatter plot first. Now, just ignore the red line that you see on the screen right here. We're going to need to know the equation of this line for the next section, section 4.2, but we're going to ignore it for right now. When looking at the scatter plot, we can see that the dots are all forming some sort of linear relationship, a linear direction here. It's kind of easy with the red line to guide us in the direction. But we also want to be able to notice that it is a positive linear, a positive direction as well, meaning that as the club head speed is increasing, the distance the ball travels is also increasing. Now, what do we think the relationship or correlation coefficient is going to be for a dot plot that is, that's scattered like this? We can go back to the previous screen and notice that, nope, not that number. Notice that right here, the R value, the correlation coefficient, is going to be 0.939. So remember when we were describing this from previous screens, any R value that's close to positive or negative 1 is going to give you some sort of a strong relationship between the two variables. This number, 0.939, is indicating that we have a strong relationship between the club head speed and the distance the ball will travel. Now that's the main way that we're going to use the technology to not only show a scatter plot, but also be able to show the correlation coefficient. Another way that we're going to use to determine whether or not there's a relationship between these two variables, the club head speed and the distance, is going to be to use a table of critical values. So to do that, what we need to see is a table that's going to be given to us either in our homework or if we were to look it up on our own. In order to use the table, we need to identify the critical value that's associated with the sample size I'm using. Notice here my sample size for the data was a sample size of 8, and over here in my table of values that are just given to me automatically, if I follow the left-hand column down to a sample size of 8, its corresponding critical value is 0.707. Now, what do I do with that? Well, we need to understand this relationship right here. The absolute value of R needs to be greater than the critical value in order for us to conclude a linear relationship. So the absolute value of R is greater than the critical value means there is a linear relationship. We remember that our correlation coefficient of 0.939, the absolute value would of course always mean that it's going to be some positive value. And 0.939 is obviously greater than our critical value from the table below at 0.707. That would indicate we would have a positive linear relation based on not only our critical value test, but also our scatter plot and the correlation coefficient. So when you're looking at this, we will typically do a scatter plot to indicate direction and make sure that it's linear. We then would look at the correlation coefficient and use that value to determine the strength of the relationship as well as positive versus negative relationship. Again, we said that a 0.939, anything close to 1, is going to be a strong relationship. And then finally, we have this other method that should give us the same conclusion by using the critical value table to evaluate it against the correlation coefficient that technology is calculating for us.